Hey guys, today we're talking about adding and subtracting inequalities. So let's look at this situation. Mr. Jacobson is driving Elias and his friends to the school dance. The car can carry up to 5 people, so the maximum number of people that he can drive is 5. It's him, Elias, and their friends. So we know that there's 2 people, but we don't know the exact number of friends. So how many friends can ride in the car with them? The key here is the up to 5 people. This is a real-world situation in which this inequality, x plus 2, is less than or equal to 5, and x represents the number of friends that can ride in the car with them. So if we look here, and if they have 1 friend, and we plug it in, 1 plus 2 equals 3, so it works. If we put 2 in, there would be 4, so again that works. If we put 3 in, there would be 5. Even though it's 5 is less than, this equal to sign means that it does work because it can be equal to 5. If we put in 4, we're going to get 6. 6 is not less than or equal to 5, so this is where our answer starts becoming no. So anywhere from here and on, these 3 work, but this one does not. So an inequality is going to be a sentence that compares quantities. We're going to be able to use this table right here to help us create our inequalities. So please take a second and write down these words because they might be new to you. For example, this one is less than or fewer than. This one is greater than or is more than, and it is also exceeds. This one is going to be all of your less thans, but also equal to, and then no more than or at most. While this one is going to be greater than or equal to, no less than, or is at least. Okay, so let's look at this one. We've got 6 is greater than -3. If I add 5 to both sides, I still get a true statement. 11 is going to be greater than 2. If I would go back and subtract 2 from both sides, I'm still going to get a true statement. 4 is greater than -5. No matter what you add or subtract, you're still going to get a true statement. So this helps us when we're solving inequalities. For example, if I have this expression right here, or excuse me, this equation right here, it's an inequality. X is going to be greater than 7, which means X can be any number that's bigger than 7. It cannot include 7. While with this one, if I add 5 to both sides, I get -1 is greater than or equal to n, which means that n has to be less than or equal to 1. It can be a -1, or excuse me, not a 1, but a -1. It can be a -1, but it can be anything that's less than -1, but it cannot be greater. Go ahead and try these 2, and I'll be back in just a second to show you what I did. So you should be trying these in your notebook and then grading it with a red pen. So here's what I did. I'm going to add 3 to both sides, and when I do so, I get A is less than 11. Over here, I'm going to take the 4/10 away from both sides, and I get a positive y is greater than or equal to 6 6/10. Can you check your work? Sure, you can plug it back in and know that 6 6/10 plus 4/10 gives me 7, and 11 minus 3 gives me 8. So you can check your work. Now let's talk about graphing these. You can represent these answers on a number line. For example, in this one, I would take 1/2 away, and A would be less than 1.5. Okay, so we're going to graph this. I put some numbers on my number line, and I'm looking for 1.5, which would be right in between the 1 and the 2. Now, here's the key. It's got to stay an open dot because it's not going to be 1.5. It's anything less than 1.5. So any number less than 1.5. So I'm going to draw an open dot and an arrow pointing to the left. On this one, I'm taking away 3. So n is going to be greater than or equal to 3. So again, I'm going to make my numbers on my number line. But notice this time that it's an equal to. So I'm going to make a closed dot, which means on my graph, it could be 3, and it could also be any number that's greater than 3. So I'm going to draw my arrow to all the numbers that are greater than 3. Go ahead and try these, and I'll be back in just a second to show you what I did. Grab your red pen. All right, so on this one, you're going to take 4 away. So A is going to be anything that's greater than 0. Let's plot it on our number line. You don't have to go too crazy with your number line. Now, open or close dot. Think about it. Is it equal to? No, so leave it open. And it's any number that's greater than 0, which would be all of these numbers. Down here, we're going to add 6 to both sides. So x is less than or equal to 10. Again, you don't have to go too crazy. You can just put 1 or 2 numbers before and after your number that you're using. So 10 can be 10, or excuse me, x can be 10. So closed dot, and then it's anything less than. So any number smaller than 10. Let's look at a word problem. Dylan has $18 to ride go-karts and play games at the state fair. Suppose the go-karts cost $5.50. Write and solve an inequality to find the most he can spend on the games. So he has no more than $18 in his pocket. So we know the cost of the go-karts plus the cost of the games must be less than or equal to his total amount. So let's plug in. The cost of the go-kart, he's riding 1. The cost of the games, we don't know. It must be less than or equal to 18 because he can't exceed this 18. So if we write this, this is our inequality. And now let's solve it. If we take $5.50 away, he's ridden the go-karts, and now we just have the games left. So he could spend, so we get $12.50 that he has left to play games. Okay, now I'm going to let you try one. Jerry took $20 to the store to buy a book and some CDs. If he buys a book that costs $4.50, write and solve an inequality to find the most he could spend on CDs. And then make sure you interpret the solution, okay? I will be back in just a second to show you what I did. All right, so in this one, we don't know how much he's spending on CDs, but we know he's buying a $4.50 book. We also know that he can't spend more than $20, so 20 has to be greater than the amount that he spends. It could be equal to the amount that he spends, though. So if we take $4.50 away from both sides, we're left with x is greater than or equal to $15.50. So what does this mean? Let's interpret it. You could write, at most, he could spend $15.50 on CDs. You could also write, he could spend no more than $15.50 on CDs. Or you could even say he could spend less than or equal to $15.50 on CDs. Please make sure you have all 3 ways that I showed you. And that's all I've got for you. See you next time.